This is a resistance required practical. So in the resistance required practical, you need a power source, whether it's cell, battery, power pack, whatever it is, you keep it the same, you keep it your control variable. You need an ammeter in series, and you need your voltmeter in parallel over the component or resistors of interest. In this practical, it's a wire. We have a variable resistor to change the resistance, which changes the current, keep the current constant. We want to use constantin for the wire, so that resistance doesn't change its resistance. So the wire's resistance doesn't change, we keep that as a control variable. And what we do is we change it. We change the length of the wire by using crocodile clips. So start off with the full length of the wire, then you move the crocodile clip lower and lower and lower and lower. But you don't go to really short lengths such as 8 centimeters, because the shorter it is, the hotter the wire is going to get and you could burn yourself. When you're taking your readings of the ammeter and the voltmeter, you want to turn the circuit on briefly whilst you take your readings and then turn it off. The reason why we turn it off is so the temperature doesn't increase, so the temperature doesn't affect the resistance. On the graph you should get, when you plot this, when you plot the length of wire in centimeters or meters, don't forget to convert units, and resistance, you will get a straight line. You will get a nice straight line, it's directly proportional. And to calculate the resistance, you use resistance equals potential difference divided by the current. So what you should do is use a variable resistor to keep the potential difference the same. What you should realise, as the wire gets longer, the current decreases, which is showing the resistance is increasing in a directly proportional manner. We can use exactly the same circuit to do resistors in series. We keep the variable resistor the same, we keep the same power supply, we keep the ammeter in series, we keep the voltmeter in parallel. This time we swap the wire for 2 resistors in series, and we can use R equals V divided by I. We can also take out the resistors in series, put in resistors in parallel, and then we should see that the resistance decreases with the number of resistors in parallel. And that is the resistance required practical revision video.